Good morning, class. I hope your homework went okay from yesterday. Again, I will state that today we are only talking about the surface area. We do not have to do the volume of anything in this chapter, although you shouldn't forget how to do that, but we will not be requiring you to do the volume. So the first thing we're going to talk about today is this idea of prisms. We've mentioned these many, many times before. If I was able to be in front of you, I would get out my little shapes and I would put anything that comes to a point that has a base of some sort, like a rectangle. If it comes up to a point like a cone, that it's not a prism. By definition, a prism is an object that has the base and the top the same shape. So there's some examples right there in front of you of what a right prism is and an oblique prism. We don't deal much with oblique prisms, but you can see it looks like it's been kicked and it's slanted. We're just going to be dealing with right prisms. By definition, a right prism has 90 degrees in the bottoms of all these angles down here, where this one is not. Okay. Some other words you should learn. Lateral. Lateral means sideways. If you have lateral movement, that means you have good sideways movement. So this lateral word, you can think of it as meaning the sides. So the lateral faces of a prism are, if they are rectangles, it's called a right prism because you could see that all of these sides here have 90 degrees in them. And otherwise it's called an oblique. The length of the lateral edge of a right prism is its height right there. So the length of this lateral edge there is called the height. And if you were to add up all the pieces that are standing upright, those would be the lateral area, the lateral faces. Again, I'm not sure how many of those words you'll need to know, but we are going to find the surface area of many prisms. Okay. We are not doing volume. We're only doing surface area. And it says the surface area is a sum. The sum of its lateral areas and the area of its two bases. So basically, go find the area of all the sides to find surface area. Those are some examples of some right prisms. This one in particular, sometimes you have to lay those down. You could see that the triangle right here is the same as the triangle back here. So even though it's standing upright, you could lay it down and then the top and the bottom would be the same. Same thing with that shape right there. Right now, the top and the bottom are not the same, but if you were to stand it on its end, that gray shaded part, if you were to stand it up like that, then the bottom and the top would be the same. So in this book, they always shade to you what the base is. They always shade that. So you have to think of putting the shaded part down on the ground, and then you could see that the top and the bottom would be the same dimensions. Okay, so this is a very short lesson. You just have to take apart this triangular prism. The base is a triangle and so is the top. You have to take it apart and find the area. This is not difficult except that there are a few unknown things. So I usually start with the top and the bottom, the base and the top. So when you do that, you have to remember how to find the area of a triangle. So the area of this triangle is base times height divided by 2. Now, you have to decide what the base and the height are. There's a trick to knowing, and that is take the 90-degree angle, and where that 90 degrees is, the height and the base of that triangle are formed in that 90 degrees. So the base of that triangle, if I want to do the triangular portion, I would do 6 times 8 and take half of that. Now, some kid is going to say, oh, yeah, but don't I have a top and a bottom? You do. So in the end, you can do it quicker, but right now I'm going to show you step by step. And then here's where we say, okay, yes, that's true. That's the bottom, but now I have the top. So really, could I not have done this 1/2? And the answer is yes, as long as your top and bottom are exactly the same. Nevertheless, I want you to know that the area of a triangle is 1/2 times the base times the height. Okay, so now if I switch colors and I go and I get this rectangular shape here, the dimensions of that are 12 by 8. So I'm going to go 12 by 8. Okay, how about this piece over here? What are the dimensions of that? Well, 6 by 12. I have one piece left, and that is that back piece. And what are the dimensions of that? Well, I know the one side is 12 right here, but what is this length back here? Oh, I don't know. Let's do the Pythagorean theorem to find out. So that is exactly what they're doing right here. They are finding the length of that back side by doing a squared plus b squared equals c squared. Now, I don't care what you want to call the letters. What is important is that the hypotenuse is the unknown. They're calling it x, and it has to be by itself. So that x squared equals 6 squared plus 8 squared. Do the math, and you will get that the size of that is 10. So now I can put in my piece over here. It's a 10 by 12. Now you take all of these pieces together, and you add them up, and you will arrive at 336. Notice they put 336 centimeters squared. Leave off the centimeters squared until you're all done. And when you give me your answer, then put your units in area. Area always is found with squaring your units. Okay, that is really the only thing that you have to do, the only thing to show you, and that is to take apart your picture. But I want to skip down to the homework sections, and I want to help you with one more question. I am not going to do example 2 for you. I don't think you will have that more complicated of a shape. So let's go down to here to example, to the exercises on page 59 for 2.2. And I want to work on a question with you. Okay, maybe let's do letter D. I'm going to do it with you for simply having more practice. All right. So if I wanted to find the surface area of that entire shape, is it a prism? Yes. It looks like a tent right now, but if you put the tent on the door, if you make this be your base, then it does have the top and bottom being the same shape. You can see here. So it's a prism. Okay, so let's go find the area of it. I'll erase those lines. So if I want to find the area of that, I like to do the rectangles first. Maybe I'll do the bottom. I have a 10 by 20. I only have one of those. Then I have this one back here. It's 20 by, I don't know this length. This is the same, by the way, but I do not know this length right there. Is there any way to find it? Well, yes, of course, Mrs. Sewell. You can take this piece right here, this triangle in the front, and I can find the length of that hypotenuse. Now, because they had those little marks on it originally, on that 10, it was cutting into 2 equal parts. That means one of these is a 5. So I'm just going to take this right triangle right here. This is 5 and this is 7. I'm going to find this piece. So I'm going to say a squared plus b squared equals c squared. Okay, I would strongly suggest that you take your square roots. I took the square root of both of these, right? Take your square roots to at least 2 decimal places so you don't have any mistakes there. Okay, so that's 8.60. So now when I go to find this red rectangle up here, I'm going to say 8.60 times 20. Do I have 2 of those? Yes, I do. So I'm taking this and the 344. What do I have left to do? Well, right now what you have left to do is you have to find the area of this triangle. So that triangle is 10, it's base times height. So it's 10 times 7. And I would cut that into 2 pieces or take a half of it, but I have 2 of them. So I'm just going to end up with 70 left. That looks like x squared and it's not. Okay, so now I'm going to take all of those pieces, add them together, and get 614 centimeters squared. Please give me your answer in some way that I can tell what you're doing. Show me all your steps. Okay, hopefully that helps. Good luck.